Hey guys, this is Gary coming back to you here with another video at 6 a.m. on Wednesday morning. And as you may be able to hear in the background, it's raining. I always do my video editing early in the morning, so I'm trying to do a voiceover to get this video finished up, and just bear with me on that. So this project is for a longtime friend of mine named Clair Finkenbinder. Clair lives up in the central Pennsylvania area, Mechanicsburg, Harrisburg, York, all in that part of the country. So I used to work with Clair, and we've been friends since then. He's a big time car guy. He's restored several old cars, a couple Mustangs, and he owns a race team. They've had a few different cars. So this video is about the latest project that Clair has taken on, which is a 70 Restomod 70 Boss clone that he's done a 427 Clevor engine in it, which is that hybrid, Cleveland and Windsor setup. It's got a fast fuel injection and all suspension upgrade, mini tub, pretty much everything you could think of done to this car. And when he mocked up the wheels, he used some, I think, 20s, and then when he ordered his wheels, he decided to go with 18s. Well, when he got the wheels in, he didn't have full turning ability up front. It was hitting the upper control arms. So what he's asked us to do is lower the mounting point of the spindles by 1 inch so that he can lower the upper control arm by 1 inch to get the clearance that he needs. That was going to be his best option. And normally I wouldn't work on any suspension parts and make any changes like this, but since he's a friend, I mean, if he gets killed by some crappy machining and welding that I've done, then then it's too bad, so sad. I'm just kidding. This is, you see some pictures of Clair's car here, and of Clair himself, and the picture of Clair and his girlfriend. There's only one good-looking face in that picture, and I'm sorry, Clair, it's not you. All right, so let's just jump into this thing. The first thing we're going to do here is cut and machine some 1 inch extension blocks. So we're over here at the bandsaw, getting set up to to cut that out. And what I did was I just took a piece of 1 inch plate that I had left over a little while back. You guys may saw a video where I cut these 1 inch plates, and so I just cut a little strip off of that on the bandsaw. And I'm trying to speed through this as fast as possible. A lot of times on the bandsaw, I don't let it, I'll just let it run and take as long as it needs to not force it through there. So just doing a quick deburr and clean up on the edges so we can get it to fit in the vise. And now we're gonna just machine this thing. We've got a 1 inch end mill in the mill, and you'll see us go through and mill all the surfaces to get it as square as we can, and deck the top and bottom to remove the mill scale. So I try to always get you guys the best camera angle I can. Sometimes I might be having to shoot through different things. You can see the light there in the bottom of the video coming sort of from behind the mill table. So you see we're just taking some skim passes off to true up these edges. And before I started this, I did trim in the mill head and the vise to make sure we were good there. And the vise had moved to about 2/1000ths out just over time, and so we got that back into square with the spindle. So you see we just I milled the two ends, and then I turned it long ways now that those are square, so we can reference off those in the vise, and then take some passes on the profile. So here we're just gonna I just used a Sharpie to lay out a couple of lines to cut our blocks to the right dimension, now that we've got our overall block square all the way around. So you can see the lines that we scribed. and this ended up being too small to fit in the horizontal bandsaw, so I just manually pushed them through on the large 26-inch dual bandsaw. So now there's one edge of it that has an odd shape to it, and I've got to, you know, cut a profile into the back edge to fit up against this oddly shaped part of the spindle. So I just used some tape and an X-Acto knife to rough in that shape, to mark and transfer some lines. And so once we got that shaped out, you can see, you know, it just spent a little time getting the paint removed, and you see the profile fit up there, and the I cut a little bevel in it to give us plenty of gap to do the welding. So here you see we got it clamped into place, and just getting some tacks on it. And I have the welder on 200 amps all the way up. And one of the things you'll notice about welding this is it's a very awkward piece. You know, this just really frustrating to work with for sure. But you see we got the tacks on it there. Now we're just going to go ahead and start getting it welded all the way around. You'll notice that, you know, my behavior on this, you know, when I'm welding something, I'm always working to try to get the piece in the best position I can, and getting myself propped the best I can. And that's really one of the keys to getting, you know, your best welds, you know. And I'm not a great TIG welder. I do okay at it. And I always get my best welds when I spend extra time to try to get my hands and everything in a comfortable position. So you'll always see me kind of moving it around, trying to get it propped and get a good angle. I have a flex head torch, so you'll always see me adjusting that as well, again, to try to get the best angle I can. Be nice if all the welding I did was like Texas Viking, where everything perfectly fits in a rotary table, or whatever that guy has the most amazing setups, you know. I mean, and of course this welds come out perfect every time, because he's a good welder, but he also, what makes him a good welder is he's got the perfect setup. And he, you know, a lot of the parts he welds are, you know, very concentric and round, or, you know, that kind of thing. So you see here just kind of fighting with it, trying to get it in a good position. Some people might wonder about, you know, I'm using an ER70 S6 rod, a 330. It's a 332nd rod and a 332nd tungsten. And you know, some people might say I should have preheated that part a little bit. It probably wouldn't have been a bad idea. But it seems to have held up okay. And later, when you see the machining, you know, I didn't notice any issues with the weld or any, you know, possible cracks or anything in it. But Clair needs to definitely pay attention to this thing, and for a while after he gets it on the road, just keep a check on, you know, the welds, and you know, look for any issues that may come up. So I did the same thing to both of them, and didn't show both of those up close, but here you can get a pretty good look at the weld all the way around. You can see by the heat affected zone that we got good penetration into both pieces. You know, probably a good 3/16 to 1/4 of an inch. All right, Claire, check it out. This is what I came up with to be able to mount your spindles so that I could mill and drill. So I'm just got an indicator set up, and I'm just indicating it across this way to getting it perfectly flat with the spindle of the mill. So I use this 1.5 inch piece of scrap, 1.5 inches thick, and I've got just one toe clamp on it now, but I'm gonna put about 5 on it. And I've also got T-slots down here. I'm gonna run a T-nut in there and clamp it here as well, and right here. So it'll be clamped in there pretty good. It's still not gonna be super rigid because you got this space up here that's unsupported, but I need to use these machine surfaces on these bosses right here that were perpendicular to that machine surface. So anyway, getting close to being able to get going on the milling, and that'll be the easy part. This is I've got several hours into coming up with this. See ya. All right, guys. Well, what you've seen in the video so far up until now is that we machined this 1-inch block. We got it fitted up, fit the contour there. We got that TIG welded in. And since you've seen that, what I've been working on is coming up with a way to fixture this in our milling machine. As you can see, this thing is extremely awkward, and normally, obviously, regular parts you just clamp in the vise or clamp it down to the work table directly. But with all this spider leg stuff going on, we needed a way to do that. So what we were able to come up with is that there's this boss here for the cross bolt has a machine surface that's perpendicular to the top. So we knew if we could square this up to the table, that the top could be squared up as well. So we got that done. Took a piece, this is just a scrap piece of 1.5 inch bar stock here, drilled a few bolt holes in it, and then we cut out a piece of 3/8 inch block there and TIG welded it to get a 9/16 bolt to fit through that. So we have it bolted here, bolted there. We got it about as rigid as we can get it. You can see that there's a section here that's sticking up. It's going to create a little chatter, but we're going to go slow. We're going to take some easy cuts with a 1/2 inch end mill and work our way down on it. We got to take a 1/2 inch off of this. Right now it's 1 inch 800 thousandths, and we want to take that down to 1 inch 300 thousandths roughly. Those are just rough numbers. I'll get the real numbers and go for it. But anyway, I just wanted to give some commentary because so far all you've seen is just some welding and cutting and stuff like that. So let me get this camera set up and we'll take you through the rest of it. All right, I was going to show this real quick. We're locating off of this bolt here, and that's the main mounting point. And then we've come down here and made this 3/8 inch tab with a hole in it that's a perfect clearance hole. I mean, it's and then we'll come in and we got a chamfer on the back edge of this. We'll TIG that up right there. I'm actually showing you this out of order. This is the second setup. I've already done this once. I had to cut this tab off the other side because we have front suspension and we've got a right and left. So I took it all apart, reversed everything, milled a slot out for this recess area for this to go in on the reverse side of our jig. And then now we're just getting fit up here with this 9/16 bolt, and we'll TIG that up just to hold that in place. It doesn't need strength this way because this bolt has it secured that way, but we want to keep it from wanting to, to pivot on that bolt. We've got this bolted here. And again, this is the second setup. The first setup, I checked everything along the way, checked the tightness of the bolts, and you could just see how the milling was going. Everything was staying put. When we would sweep across the top, it would be level and so forth. So and on this second setup, what I've done here is I just cut a piece of 2x4 and stuck it in this gap, and I got a cant twist clamp on there. I realize this is not perfect for machining, and had I thought this jig out a little more, I could have probably come up with something better here. Maybe a little machinist jack with a ball on the end of it. I don't have any machinist jack, so I could have ordered one. Probably would have been a good use for that. And then the clamp on the outside of it. But I really need anything I can do to give a little more rigidity here because, I was only able to take about 30 thousandths at a time with on the previous setup. So hopefully this will let us get a little more aggressive with it here, and we'll take you back to the other footage that you've been watching on the first one now. All right, so you saw our very slow process there, and you can definitely see the evidence of chatter on our surface, and it was definitely wanting to chatter quite a bit there. But we got this down now to the dimension that we're looking for. I've left it 10 thousandths tall. So what I am going to do, you see we've changed this out for a 3/4 inch ball end mill, and I'm going to touch off, go down 10 thousandths to get this to our final goal. And then the reason I put the ball on there is to create a radius in here so that we don't have this hard edge. And I'm going to move it over a little bit, and the final fit up, I don't know what that's going to be yet. I may have to come back and touch this again with the ball end mill to get the clearance we need. But the tapered stud for the ball joint, you know, is going to sit down in there further. We're going to have to come back and drill, open this up a little bit, and then drill all the way through this solid piece, and then run our tapered reamer in there. So go ahead and get the ball end mill going and show you what that looks like. All right, I got you set up here. Hopefully wanted to give you just a little angle on this ball end mill. I may be in your way a little bit here and there, but I'm gonna try to stay out of the way, make a couple passes on it, and show you what we're doing. So we're gonna get it fired up and touch off, take 10 thousandths, and work our way in there. All right, we're touching there. So there's 10 thousandths. All right, hopefully that's showing up in the video there. You can see the ball end mill put a nice stress relieving radius on Okay, I took the ball end mill and I used that to find the center of the existing hole, and I just opened the hole up with the radius of the ball end mill to 3/4 of an inch from whatever it was, because our new taper is really going to start down in this lower section here, and this up here is just really you know, in place to give it support, so that we just didn't have it welded back here. We got the whole thing encapsulated, so I think it should be pretty strong. So I'm going to get the air going here on our Noga Cool Mist and get those chips evacuated. So we're going to use a few different size bits here on this. We're going to do a 1/4 inch hole here to get it going, and then we'll work our way up progressively to create a stepped hole so that our reamer, tapered reamer, has a little less work to do. So we'll get this pilot hole going here. So we need to know that the bottom of the hole is, we know the bottom of the hole on the existing one was 550 thousandths, and I've got a, let's see, 17/32 bit here, which is I think 520 thousandths. And again, this will allow us to save on the wear and tear on the tapered reamer. So just lowering the knee a little bit to be able to get this in. I'm gonna have to go a little lower with it. And running about 1300 RPMs on that 1/4 inch bit there, so we're gonna slow this down to a more reasonable speed. See if we can get it to run slow enough in high gear. If not, we'll go to low gear. 600 RPMs is my slowest in high gear, so we'll have to go to low gear. All right, and now we're going to go to a 5/8 bit and drill in a little ways. And I'm going to take a couple measurements on the other one that we've not yet completed to see how far I can go in with the 5/8 bit. So far our hole looks good. All right, I just did a quick measurement on the existing one. The way it, the way the taper was working is about 1/4 of the way in is where 5/8 that it went inside 625 thousandths. So I've got a 5/8 bit here that we're going to use, and we're going to go in about 1/4 of the way with the 5/8 bit, and then we let the reamer do the rest. So we're going to lower the knee. And you probably can't see that now, so let me adjust you a little bit. So I'm just going to go slow and keep a look at it, and that's really it. Just 1/4 of an inch in, and we'll get our reamer set up and go from there. I'm going to change this out. I'm going to run that reamer in a, it's got a 1/2 inch shank on it, so I'm going to run it in a 40 taper tool holder to get a little more, less run out. This drill chuck's got a lot of run out in it, which is fine for the roughing in of the hole, but with the reamer we want to get that thing not wallowing out the hole and running really concentric with the hole. So let me swap that out. All right, so we got our tapered reamer in there, and I was just doing a little research on the feeds and speeds on these guys, and it just, as a general recommendation, it just says, you know, turn it at the same or 2/3 the speed that you would a drill. And our hole on the small end is again 550 thousandths, roughly in that range, and the large end is 670 thousandths. So we are going to turn this at 2/3 the speed of a 5/8 drill, and which is normally around 600 RPMs, and we're going to turn this at about 300 to 400 in that range. We'll tweak it, and if we get some chatter or whatever, just make a little adjustment. Again, I'm dealing with this non-rigid setup, so we're going to go really slow, and what we're looking to do is get the bottom of the hole here at 550 thousandths, and we know when we reach that, we're going to have the hole set up correctly at the right depth with the right taper and all that. So here we go. All right, we're gonna just, I lowered the knee down a little bit and we're gonna take this out so we can do a test fit. And not mess up our placement in case we need to ream it a little more. It's a couple thousandths short, which I think I'd rather be a little short. We got room, you know, even if the customer, when he gets it, wants to do a little hand reaming on it, you know, he could do that. I'm just gonna blow this out with this air. Be able to check our clearance on this front piece here. Oh yeah, there's plenty of room there. Oh, but we're not coming through, huh? It's weird. All right, let me go back and see what is going on with this. And I'll give you an update, and once I figure out why that's not fitting better. All right, Claire, this has been quite a project. It's been fun. I've enjoyed working on it, and this first one is done. Second one should go a little quicker. Learned a few things on this one, you know, which end mill to use, what speeds. The fact that there was no good way to clamp this because it kind of tapers off on an angle back here. There's no way to clamp it up tight up top. This unsupported area just really makes it unstable, and you can't, all I could do was take a 32nd of an inch at a time off with an end mill. I'm making a full video on it, so you'll see it in the video, but I got this one fitting in, your cotter pin hole. See that? I don't have the bolt, you know, fully lined up, but see your cotter pin lines up in there. And before we had 5/8 of an inch gap between the bottom of the ball and the top of your flange there, or the boss. And we took a 1/2 inch off and we reamed and drilled this to lower it an additional 1/2 inch. So if you take the 1/2 inch away from the 5/8, you got about an 1/8 of an inch gap there. So I used a 3/4 inch ball end mill to give this relief, so there's not a stress riser there. Now you can see there's good articulation, but right here it does bottom out on this. I'm gonna leave that like it is. It may be fine. I don't know, you know, how the vehicle rides. So what you do is just bolt this up, and if you get some touchdown or movement there when you try to turn it or whatever, you can just take a file or a grinder and knock that down to get it, you know, we want to leave as much of that on there as we can just to give it strength. So there you go.
Well, Gary, here it is. The spindle you modified for me because of my mismeasurement on my wheels. You can see the portion that you added to the spindle and how you countersunk the ball joint, you know, much deeper into the spindle. You'll notice a bracket that I fabricated in the rear. Previously, the bracket was just a 1x1 piece of aluminum stock. I created a bracket 1x2, relocated the arm down 1 inch to pair up with the 1 inch you relieved from the top of the spindle. And the next step is to get the hub on and bolt the wheel on to see how we do. So I'll give you an update here a little bit later. Thank you.